Great. Yeah, so why your code is functional and how to handle it. What I'm going to talk you about today. Well, usually there should be some introduction, like my name, my company, and anything. I'm too lazy for that, so I made my introduction very small, like I'm an anonymous alcoholic, which is, hi, my name is Roman, and I love functional programming. So I'm here to confess about it to you all. Sorry, that happens. And because of that, when it happened, I started to use functional programming in quite a lot of different languages, which is, well, yeah, that list. And I guess it's even more because it's quite an old slide. It should be updated since then. And, you know, all these languages are quite different in its approaches and in how it works at all. But I always insist in like saying that ideas of functional programming could be equally used in very different languages, approaches, environments, projects, anything. And the thing is not even that they can be used. They already used. I always think that every language already took so much ideas from functional programming that is kind of crazy. But in most cases, you have no idea it's even related to functional programming. So yeah, and usually when I talk about that, people see me like somehow like, hey, would it work? Yeah, somehow like this person who comes to you, hey, that's funky, met him, who comes to you explaining that, hey, only you can stop object-oriented programming. You should not write a single line of OOP in your life ever again. If you would, I will find you and you won't like it. So yeah, usually people look at it like this, like you should only use functional programming and OOP is just, well, obsolete and old, sorry. It's not. As a matter of fact, okay, as a matter of fact, you can use both approaches in the same time because OOP could be easily combined with a functional approach and practically with anything. That's the power of OOP. And today I won't talk you how to write your whole application in functional style or anything. I would much more talk about like tricks from functional programming that you can use in your code. And yes, it could be of use and could make your life better a little bit. So yeah, but first of all, some important question. Oh yeah, I have a slide for that. Damn, I forgot about it. So yeah, I will repeat it again. So we are going today to talk a little bit about what is functional programming, because it might be good to explain before talking about it and why it's even important. I'm going to explain what exactly ideas functional programming inspires and how we can use it and how we can even better use it than we do it right now. And also how these ideas changed modern software architecture. So to make title of my talk, well, I don't know, a little bit real and not just made up. So yeah, chapter 1 is about why there is so much functional programming around us, talks in code every damn where, and what that even is. So there's a lot of definitions of what functional programming is. You can go to Wikipedia and find some. I love these definitions from internet. They're usually short, loud, and explains them nothing. So I think it's a good tradition. I would give another one. So functional programming is a paradigm that describes a program as a set of data transformations. I know it not explains a thing. That's the definition. Definitions are for that. They're for making effect, not for explaining stuff. So I would explain stuff a little bit longer. Let's say we want to transform ID to card data. So we have a function, I don't know, find card data, where we send ID of our card and receiving card data, right? Quite the usual stuff. Then we want to use this card data somehow. Well, okay, we use this card data to draw a card image. Well, why not? It happens in banking applications. Then we want to respond with this card image to our application back, right? So we transform a card image to response. Let's imagine that, well, that's all we have. So we transform in our request original to IDs and ID card data, card image, blah, blah, blah. And in the end, we receive a response. If these transformations are only things that happens in our application, that is functional application. If we do nothing but transforming data, great. Your whole program wrote in functional style. Congratulations, you achieved something. God knows what. So yeah, and finally, our application, we can also show it as one program, if it is. We just transform request from response. So basically, we can say, hey, whole HTTP is a functional program. But it's kind of not as simple as that. We'll talk about it later. However, what we have here is two data types, request and response, and pure function in between. So we have data type 1, data type 2, and we have functions that explains how to make 1 into 2, request into response, and so on. And what is pure function there? Well, first of all, pure function is something that does not mutate a state. So again, ideally, pure function is only doing one thing: transforms state A into state B. So it does not change anything that's not exactly inside this function. So for example, if you have in your function local variable, it's okay to change it. Who cares? It's local. It's only inside your function. But if you have something outside your function, no, you shouldn't do that. Also, the functions have no side effects. So we're not only not changing variables or anything outside of it, but we're also not writing something to console. We are not changing the world story. I mean, programming is not changing the world at all. You're just lying to yourself. But yes, this function specifically does not change anything. And also, this function always has the same output for the same input. So for example, let's imagine we have some function with a fancy name calculate, quite an interesting one. And if you pass this number 5 to this function, it would always return number 10. It Monday, Friday, any moment when you deploy, when you're not deploying, anything, anywhere, always. It's always 10, any moment. So it does not include random in it. It does not depend on time or anything. It's always same output. So yeah. It's quite hard to get. So there's always a question, what would we even get if we, well, do all these ceremonies? Back to Alex. So yeah, do we do it just to do all the ceremonies, or do we get something in return? Well, we do. First, and the most fun thing is parallel computations. Practically, if you have this kind of functions, you can execute it in any number of threads and nothing would happen because, well, you're not mutating anything, so you don't give a fuck in how much threads you're executing it. Great, nice, thanks. The other thing is that it's much easier to debug and test. Explanation is quite simple. Again, I said that we have a function that with the same input always returns the same output. God, it's a dream. So you can write the easiest, easiest any test in the world. Integration, unit test, anything. Because, well, you just want to make sure that with these parameters, it would be always the same output. Quite simple. And also, it would be much more fail-safe. I would show why later. But practically, the less dependencies you have outside your function, well, the less times it fails, because it has much less reasons to fail. So yeah. And another thing that's pretty often forgotten is that you can easily hot reload or deploy your application because it does not have dependencies. And usually the problem about reload your application, well, exactly dependencies. So no, you don't have dependencies, you don't have state, so you don't care. You don't just have a set of functions. And one day, all the stuff that I just said became more important than ever. And you can guess what happened. This happened. Intel Core i7 with giant number of threads and practically the same efficiency of one thread. So we have a lot of cores. We want to use all this shiny new functionality, but well, you know, you have to do multi-threading, you have to do concurrency, and oh, we spend half our time implementing concurrency. Oh, we have a lot of bugs. Oh shit. Oh god. And now you want to find something that won't fail because of concurrency exceptions, and that is much easier to scale. Well, functional programming looks good. And then the other day, these guys happened, and well, bunch of other cloud guys. And yeah, if you want to scale your application in cloud, it's better to have less dependencies and state. And yeah. So yeah, when it happened to be too problematic to manage all the concurrency, some people just thought that, yeah, it's hard and it's expensive. So, you know, it's much easier. You don't need to control shared state if you don't have shared state. So yeah, that's how we ended up here in a moment when we have a lot of functional programming. And pretty often we don't even have ideas that we have functional programming because, well, it's a scary word. People don't want to use it. I can also say monads and, well, lose half of audience. So yeah, people are scared, so no one says it. But sorry, I'm going to say this word a lot today, but I will try to do it in a simple way. And here, now we know that we have functional programming that helps us to scale our modern software, cloud architecture, some other buzzwords I can say, but whatever. Yeah, sounds good. Blockchain, I'm not sure if it uses functional programming, but it might. Why not? Everyone could. So, but what else do we have besides the buzzwords and besides the help in scaling? So, here goes part 2 with some details, code, and fun ideas from the functional world, and even ways to use these ideas outside of the functional world. I would start with something very known and obvious. And yeah, by the way, disclaimer, I will have code in C#, but if I won't say that, you won't notice it's not Java because, well, practically it's Java. I mean, it's a little bit more newer and brighter Java, but you won't notice anyway. So yeah, and ways to use it outside of the world. Anyway, very old concept. Function as an object. Something that we all know about functional programming, that here we have a function and we can use a variable with function. Well, we can do it in Java, we can do it in any damn language in the world these days. So yeah, we use some function, we pass a lambda to this function, great, we have function as an object. So that's very obvious. What am I going to talk here? What if we are not just going to do it like this, but we are going to use it as variable? Oh, cool, nothing's changed. How do you think? Is lambda and like anonymous functions and so on is a new concept, or is it an old one? Who thinks that you can do it in Java, I don't know, 5? Can you do it in Java 5? Okay, who can do it in the Java 5? Raise hand. Oh yeah, there are some people who can do it. I also can do it in Java 5, and actually I can do it in any fucking language because it's pattern strategy, come on. It's so old. There is no damn difference. It's practically different interfaces for the same thing. It's strategy. It's very old. So I'm not telling anything new. It's such an old idea. But let's imagine we are using strategy not for one function, but I don't know, like for a module or for a microservice. What if we represent the whole microservice as a damn function? How does it even work? It's not sounds correct. Okay, let's take a look. Remember this function? It might be a purpose of a microservice, right? It's usually a purpose of a microservice. You send in some request, you're receiving some response. You never know how big microservice is, but well, might be this big, why not? So yeah, let's say that we have this set of functions. Can we translate it into some code? Well, of course, easily without even thinking. That's function, that's called cool. We can even say that that's functional code. Can you trust me? I mean, come on, it's functional. I'm not going to lie to you, trust me. Or I can make it this way, and now it is functional. I have a stamp there. So yeah, just trust me. Now, as you can see, it's much better. Now it looks shiny, now it looks great. But yeah, there are like some questions. You see, I can say that it's all pure functions, right? But probably in some find card function, I also have logging. And oopsie, it's not so pure anymore. And how we find card? We probably go to database. Oh God, oh damn. And we have some validations there. Shit. That's not so shiny anymore. But yeah, okay, let's try to deal with some problems. Oh, for example, validation. I can say like, hey, I have validation as the same kind of function. Now I'm just translating request into validated request. Okay, we are going and trying to write this function. We know that we are going to return if we successfully validated our request. But what if we're not? So we have the signature. It says that we are going to return a validated request. Oh, yes, that sounds great, right? Runtime error. Something we all... Side effect, yeah, another great thing. We can write to database a mistake, or to log, or something else. What a great life we are going to have. No. We are going to do something else, and usually there are two approaches to that. And for one, I would show some shit. Yeah, I mean, you can say just functional language inside, because it would be functional language shit. I would show it to you to make you scared. So it's practically the only purpose, but I would try. So how they do it in functional programming? How we do it in functional programming? God damn it. I am a functional programmer. We use the concept of result. Meet, I don't know, very boosted enum. It's usually named algebraic data types. A discriminated union in F#. Practically, it is enum that has two states, success and failure, but in each state, it can store data, and it would be different data in every state. So I'm saying like, okay, I have enum of type result. If it would be in state success, please store information. If it would be in type failure, please store information about our failure. How exactly we failed, how often, how big is our failure. So yeah, pretty simple. And then we have this kind of function. What does function do? We have result of previous function, and we have next function to execute. We are checking result of next function and asking, hey, is our previous function ended with something good? It is? Great. Please execute the next function. Is it ended in failure? No luck. Please just return the error. So we don't interested in doing anything else. And then, yeah, it would be the same kind of stuff we use there. Remember, with these binds and so on, fancy looking, blah, blah. So, yeah, it is, but bad news, it looks quite weird in Java in C#. The reason is that we don't have discriminated unions. Well, enums busted to, I don't know, the way when you can't even understand what's going on and so on. So we have Java in C#, which is not that fancy. So sadly, we can't do that. Good thing, we can still throw something like, yeah, this man says that we can do it, but he lies. He's not as happy as he looks. But what we can actually do is, yeah, we can just throw some exceptions. Not runtime exception, we will throw fancy exceptions. That's a completely different thing. Not as crappy as it is. So yeah, what we can do here is just throw some specific invalid request exception. Inside this exception, let's say, we are doing some, is this thing works? Sometimes. Let's say inside this validations, we have it in different places and so on. We don't want to throw it in random place, so we're just going to put this validation inside function. So it's much better. We are talking about functional code, please remember. So yeah, and inside this exception, we're saying like, okay, we have our message, we have our data we need to debug, and then we are going to translate this exception into something better. We have another common exception, even more common exception, blah, blah. So in some very common exception, we have all the information we need to construct a debug message. So nothing very fancy, just a business exception. But what it helps us to do is to build a proper pipeline of, well, doing everything. However, do you know what is not solved in this pipeline at all? Well, more or less nothing. But whatever, it still does not explain how are we going to do one small thing, which is, well, no, not logging. Logging is boring. Which is interacting with external services, like databases, like, I don't know, just other services, go to check some API and so on. Any ideas how are we going to do that in functional way? Come on, maybe someone knows. Because actually, I don't. I have no damn idea how to interact with database or external services in a functional way. Actually, no one has, just not working like this. It's not. It's just lying to you, sorry. Actually, I know that saying I don't know is a good thing, because when I Googled this picture, it was from Forbes article that said it's the smartest thing I can do. It's outdated, it's 3 years old, but anyway, I think it's still actual, so sorry, I don't know. But I have some ideas. It might be, but I've not tried. I will try it for the next talk. So actually, the best idea functional world has right now is avoiding side effects when we can, and grouping it if we cannot. What I mean by that? So let's imagine we have our glorious functional pipeline. For example, we need to do logging, and logging is a side effect, obviously, right? So what we can do if we don't want to have side effects everywhere, we can collect our logs to some kind of variable and log it only in the end of our pipeline, only in one place. Kind of the same goes, for example, for saving in database. We don't want to save to database everywhere. We want to save to database only in one place. And I know it sounds like kind of weird. So yeah, we're still having side effects just in this one place, and they're going to avoid it, blah, blah. The thing is that if we have whole pipeline, excluding one part, the functional pipeline, that allows us to have all the advantages, like parallel it, like test it easily and deploy it easily everywhere, but in this last part. So for example, we can parallel all our parsing computations or some other kind of computations that we can do, and only then go to something that, well, has side effects, and in this way can be paralleled easy. So sorry, no easy parallelization for database. It's still shaky, and you still have to use transactions. I'm sorry, that's life. So yeah, a little bit summary. It's not the end, I'm sorry, but anyway, of this part is that validation authorization should be a part of execution pipeline. It would also give us some advantages I would mention later. But for example, if you only take in your function some object that's named validated request, that means that you just cannot skip validation. Your function signature would never allow you to do that. And the same goes for authorization. If your validation function only takes authorized request, you cannot skip authorization either. So that's quite good because it makes errors much less possible. And another thing is that simplest way to handle errors in Java, C#, and this kind of languages is usually using business applications. You can try use fancy stuff like result and so on, but I've never seen it looking good. It always was shitty. And as big of supporter of functional programming as I am, you shouldn't, please. Never a good idea. And yeah, to get all the advantages of functional programming, you must get rid of side effects and using of external stuff. But you actually don't need to get all the advantages. So you can get some of them. What I mean by that? For example, if you have reads, your code is usually still pretty easily paralleled because you can easily parallel reads, right? It's not quite a big side effects. And even if you're writing something to log, it's still quite easily paralleled and so on, and mostly predictable because you would have the same result always with the same input, always, if you have only logs as a side effect. In this case, you're still like, well, you're kind of conducting some sins against functional programming, but sorry, that's life. That's still good. But what you have to do is to understand what exactly you're breaking and where you're breaking, and trying to minimize these problems. So you should keep your pipeline as pure as possible, and this way you will get some advantages. Okay, to some other funny topic. It is strive for totality. It sounds like a fun phrase. I would explain what it means. So let's say you have this function. It finds card. Quite cool. It finds it in some, I don't know, map or anything. Cool, right? You're just looking for a card by ID. Is it a good function? What's wrong about that? Just first thing you see. Come on. Huh? Yes, now is bad, right? We all know. Now is evil. Now it's a good function. You see? It's great. No null anymore. Only optional. Good. No problems, right? In fact, it's actually, yeah, it's much better. We can even do it with some cool features of Kotlin, C# or other modern languages. Not Java, sorry, Java sucks. But anyway, at least Kotlin and C# you can try to use that. So yeah, nullability. It's now even better. We're still returning null, but now in a fancy way. It's not the same now anymore. Now it's changed completely. So yeah, much better. Very well done. Good you. So actually, it is better. So it sounds weird, but it is. First thing is that now we have correct function signature. What I mean by that is that previous function signature, without question mark, optional, or anything, if we're looking just at signature, we have no idea if it would return null or not. We just know it would return card data, but it might be null, might be not. God knows. And if this function is longer than this, oh, it's hard to guess. And if your return result is a result of other function, which also returns the result of other function, you would never guess. You would never know. It would die in ages, this mystery. So yeah, it's much better when you somehow specify that you might return nothing. So yeah, the other moment is that you have all the null safety features. I mean, with optional, it's a little bit big and grumpy. With C# and Kotlin, you could do something like that. So for example, we find card. If we didn't find card, oopsie, we throw an exception. And if you have just now, you would have if, now, then, blah, blah, and a shitty. So yeah, again, welcome to Java, but whatever. And the other thing is that now it's much harder to get you the $1 billion exception, which is, well, cost $1 billion. So you probably should avoid it. So yeah, that's it. And now, sorry, it's time for some scary shit. Do you want to listen about some monads? Who wants? Yes. You're lying. No one wants to listen about monads. But you're actually using monads every damn day. You just don't know. Because, you know, optional is a monad. Also, nullability is a monad. You use monads every damn day. And the result I've shown you is also a monad. You practically have a lot of monads in your code, but people usually do not think what monad is. Well, that's pretty simple. So I was just talking about pipeline all the time and so on. So you have operations, right? And usually how it works, you have one function, it returns something. You want to send its return result to the next function. But what if you have no damn idea what the previous function will return? It might be null or not. It might be a result or error or something. So, well, you know, world of programming is quite unpredictable. So in this case, you're using, well, monads. Practically monad. is something that you use to connect calls of calculation chain. When you use monad, you're saying, I don't know what would exactly happen. It might be this, it might be that. Let's combine it somehow. And well, yeah, monads is just this kind of result that you can combine. You have couple of maybe null, maybe not objects. Okay, we know a way to combine them. We have a couple of maybe result, maybe error objects. We also can combine them. Oh, well, that's it. Unpredictable result that you can combine. What information that gives us? Well, first of all, that's how you combine them. So that's what all this bind function is for. Again, we have result. It might be a result, it might be error. If it is a result, then we combine it. Then we use the next function on it. If it's failure, then we just, well, send in an error. We don't need to combine in this case. We need to only preserve. So we are actually learning our code on how to combine two results. So yeah. And that means that optional or nullable is an intermediate state between functions. And that means that when we are doing something like this, so you can say that string question mark is optional, but whatever, it means that here we might have now, might have not. That's quite a bad decision. The reason for that is that we have a state. So user is a state. And in this state, we might have a mail and might not. Who knows if we would have a mail here or not? We have to always check it in every place where we use it. That's shaky. So best solution I see for that is write two damned models. Oh God, it's weird. Oh God, how come? Oh God, I'm writing now 10 lines of code, not 5. Shit, my life's broken. Writing more code. Oh no. Oh damn. But you know, it's sometimes worth it writing more code. I mean, you programmers, I guess you can copy paste. I trust in you all. So yeah. You're a dirty liar. You're a dirty damn liar. No one trusts this person anymore. Of course. Screw it. So yeah, what would we receive if we are just writing more models? So first of all, we are doing fewer checks. Because if we receive this validated user model, we are 100% sure it has email. There is no way it won't. It's not nullable field. It would always have some email. So yeah, that's some stability. And the other thing is now we have more obvious types. Because when we see the type, we always know what fields it has. Not unpredictable stuff and so on. Now we know. That's a little bit better, you know. We have lower chance of passing a wrong value. Because, yeah, when you have nullable fields, you may just randomly pass null, and null is a thing that you can pass everywhere, and that's quite error-prone pretty often. So, yeah, because it's not exactly typed, it's just null, and yeah, it's shaky. And also, you have to write more models. I'm sorry, but that's not too big of a problem. We live in the world of Lombok, of data types, and so on. In the world where to write model, you have to just write 10 names. Oh, and data types, I'm sorry. You can do that. Just trust me. Actually, my common rule of thumb is that I use more models for business models. So if I have something inside my business logic, I prefer to write more models. If that's outside stuff, like, I don't know, request that's coming to our application, or something that we receive from other applications, so something we do not control, here you can write one model with optional fields and so on, and then convert it into a business model in a controlled way. So yeah, usually if you want to use in your business logic optional fields, stop. Please just stop. Probably you're doing something wrong with your life. Keep going. So yeah, now we have our glorious function. Now it's much better. You see with the question mark, it makes everything better. What's now? What problem do we have now? Can we do something better in this great function? Come on, we can do better. Try. Any ideas? Come on. No? Maybe it's too public. Maybe we should make it private. Or maybe something else. I don't know. But what I would do is to get rid of this GUID. What is the reason? So practically, this GUID is just, well, a field, a primitive, right? So we always would have a primitive. So make no mistake, inside this pen, we have the same GUID. But why do we need this pen? Why do we need this object? Pen is, by the way, is a card number. Primary access number or something like that, I forgot. I've not worked in banking for a long time and for good. I hate it. So yeah, however, that's this number, and it only would have one field inside of it. Why do we write a module? Well, there is a reason. First of all, now we have even better function signature, because it's not just some ID, but now type just tells us, hey, it would be card number. And you know what card number it would be, what format it would have, and so on. And also, knowledge about this format gives us some other possibilities. So first of all, yeah, it makes you much easier life if you want to do overloads, for example. Because, for example, like card token is a token inside your system, how you name a card level just internally, and pen is a public number. So, well, it would be the same string, probably, but this way, it's wrapped in different objects. So now it's much better again. Wrapping makes everything better. But what's even more important is that it is harder to pass a wrong value, because, well, greet is always greet, string is always string. But if you, to use object, you have to first use some kind of, well, wrapper and so on, well, it's different. And also, here you can have validation on initialization. What does it mean? So we have this validate amount function. Let's just put it into amount object. So now all our amounts using this wrapper. What this means? If I see any instance of amount class, I'm completely sure it is valid, because I won't be able to create it if it is invalid. It would fail. I have no chance. It's only constructor. So this way, I do not need to validate amount ever anymore, and any other type. I don't not need to validate our card number or anything, because it's always valid. I can't create invalid value. And that makes your code, a little bit more stable. So yeah. And another thing is that now our code is much more immutable, because your primitives is usually immutable and so on, but you can make your model immutable. And well, when I was making this talk first, 5 years ago, I had to explain people why immutability is good. But right now, most of stuff you're using is trying to be immutable and so on, like Kotlin is by default using immutable types. So yeah, just the more immutable your code is, the harder it is to break something. So when it's harder to break something, it's usually good. Yeah. And now we can move further to a fun chapter 3 about how functional programming inspires modern architecture and what we can do wrong about all that. So first of all, we have CQRS. Who knows what CQRS is? Segregation. Yeah. So it is this glorious thing when we have our command model, we have our query model, and we just practically trying to separate writes and reads. So if you think about it, well, ideas are obviously coming somewhere from functional world. Why? Because this way, it's much easier for us to separate side effects from our logic. It's much easier for us to do less modifications and so on, because in reads, well, we actually do not need modifications. We only have reads. And also, it makes our reads much more scalable. And also, we can partly use functional pipeline advantages. Partly because reads are usually still from database, so yeah, we can't use it 100%. However, we have at least something. So yeah. And well, this gives us some glorious advantages. Another thing that goes kind of the same way is an actor model. Again, I don't know if a lot of you are familiar with actor model, but practically we are trying to create microservices, very microservices, to a level when it's actually look like a function that has their small responsibilities. And then trying to create a multiple microservices for the same function, of instances practically. So actor model was microservices before microservices, right? And old school ones. And yeah, as far as it is pretty small, we can easily isolate state from it. We can easily make an actor that, well, does not modify external state at all. So we can easily make purely functional actors. Understanding of that is pretty important when you do actor model, because you can make very efficient actors. If you do not put your side effects in your actor just because you can, well, you can make it pretty scalable, pretty fast, and pretty easy testable. Another thing is that actor model allows easily isolate all the dirty logic. So yeah, practically I explained why. And also the fun thing, I don't know if you know it or not, but actually actor model could work even without database at all. The same way as usually functional code works. So functional code is usually stores everything in function stack, and actor model is doing it kind of the same way. So it's storing information in memory of exact actor, which is, well, kind of the same way as you have it in stack of your function. So yeah, and it even helps for domain-driven design. And the reason is that in domain-driven design, we usually have objects, which are states, and they share some ubiquitous language. States should be isolated, pretty obviously. And we describe transitions between states. And when described this way, it sounds pretty much like how I describe functional programming. So your business logic in DDD could and should be made functional, because usually it makes it so much easier to maintain, trust me. And usually functional programming tricks helps you to put away all the external dependencies and describe state and work just with state. So one guy wrote a book about it, which explains the same thing much better. It's called Flashin. Just recommend it to everyone. It's quite a great one. It says F#. You can just ignore the word. Just try to see it like non-F# thing, because yeah, F# scares people. And yeah, now a little bit of results of what I was talking about. I was promising that this stuff should solve some problems. Let me tell you what exact problems it should solve. Well, first problem is the mix of pure and dirty logic. Why I say it is a problem? Because we have these advantages I mentioned. We can receive it in some cases, well, practically doing nothing. We just have to organize code in a little bit better way to create islands of pure logic, to create islands where we can use all this. So practically, you should just inspect your code and check like, hey, maybe this parsing logic do not need to call database exactly here. Maybe we can write stuff to database a little bit later after parsing is done. And wow, now we can execute our parsing on 10 threads without even like doing anything for that. So sounds quite good. And usually it's easily implemented. And the reason why people do not do that, because they do not understand what exactly they can get in return. Well, this. The other problem is that pretty often we handle the same error 10 times. The reason is, well, multiple reasons. So one I mentioned is, for example, like nullable fields, right? So we have nullable field in our model, so we do not know if it's null or not. Okay, we will check it 10 times in different places. Why? Should you? Maybe you shouldn't. The other problem is when function returns a no, some kind of null because it's error. And then you check it again in 10 times the same response. If here now, then we send another response from this function, and then we check the response in this function, blah, blah. Damn it. You shouldn't. You should either use result or throw exceptions as early as possible. And this way, you would always process your exceptions in one place, one time, and not 10 times. Because that just curse, trust me. The other thing is transition state as a field. Well, I practically mentioned it just now. You should probably remember it. But yes, that's another problem, that pretty often we have transition state as a field and we don't even understand it is a transition state. Well, it's all nullable. Who cares? We can always write now to our string. So yeah, that's all good. No, it shouldn't be. So if you have some field which is not marked as nullable, it first of all should never be null. And second, you should never have nullable field in your model if it is business model. Because yeah, it also stinks. And the other problem is primitives everywhere. It never looked like a problem, because what's bad about using God old int, string, or anything in my model? There is nothing bad about it, but also there is nothing good. You can just make your life much better. I always laugh when I say that. People are pretty often like, I don't know, trying to tell me something like, I don't know, your wrappers cost memory, so you create more objects. It takes more memory. Oh yeah. That's usually what you don't have enough. Memory for object with one field. That's true. That's exactly what you're missing in your code. So, and the problem I mentioned, like the people say, is about memory. And honestly, I've run into problems with memory only, I mean, of this kind, only once in my life. And it was in Damn Rider, I mean, IntelliJ. And IntelliJ is giant and performance prone. So yeah, and I never run into this kind of problems in just business code. So yeah, and usually people are writing business applications. Usually not even too high load. So yeah. And I never thought that a lot of code is problem itself. Problem is how you maintain it, what you do with that, and so on. If that's model that you write and never touch again, do you care that you have more code? You're not maintaining it. It's here. What we change? String itself. So yeah. So summary. You don't have to make your whole code follow functional principles at all. It's not needed. There are a lot of small tricks that can help you. By isolating pure logic, you can make scaling, testing, and maintaining your code so much easier. And you don't even need for that to isolate everything, just some pieces of pure logic. It still would be good. Some ideas from functional programming could be used literally in any project. Like, no exceptions, it could be even quite low-level stuff and so on. It's just ideas. They are not even pretty often related to functional programming at large. Just the environment inspires them. So, yeah, that's it. Thank you.